Okay, let's continue our discussion on vectors. So, dun sa previous video, in-introduce natin yung concept ng vectors, ng vector representation, tsaka magnitude. So, ngayon naman, i-discuss natin yung operations on vectors. But for this particular video, I will focus on arithmetic operations, which are addition, subtraction, and scalar multiplication. So, meron pa tayong ibang operations which are the dot product and cross products. But they will be discussed on separate videos. Okay. So, let's define the operations addition, subtraction, and scalar multiplication of vectors. So, let V be the vector with components V1 and V2, and be the vector with components W1 and W2. So they are vectors in R2. And we have K, which is a scalar. So in other words, K is just a real number. Yeah. So we define addition of vectors as follows. So V plus W is just a vector whose components are V1 plus W1 and V2 plus W2. So simple lang tong definition natin. To add vectors, so ito ay addition. To add vectors, you just add their respective components. And similarly, for subtraction, so to subtract vectors, so V minus W, you just need to subtract the corresponding components. So yung components ng V minus W are V1 minus W1, V2 minus W2. Itong third operation naman natin is scalar multiplication. So we have a scalar k and we are multiplying it with the vector v. So ang mangyayari lang, yung magiging components ng k times v will be kv1 and kv2. Na-distribute lang yung k dun sa parehong components ng v1 at v2. Okay. Now, in R3, if V has components V1, V2, V3, and W has components W1, W2, and W3, and K is again a scalar, yung addition, subtraction, and scalar multiplication are analogous. Now, since tatlo na yung components natin, of course, tatlo din yung magiging components nung sum, difference, at scalar product. So, V plus W will have components V1 plus W1, V2 plus W2, V3 plus W3, V minus W will have components V1 minus W1, V2 minus W2, V3 minus W3, and KV will have components KV1, KV2, and KV3. Okay. So what happens geometrically when we add two vectors? Now, for the purpose of illustration, I'm going to use vectors in R2. Okay, dahil mas madaling i-drawing yun. Okay, so suppose this is the y-axis. And ito naman yung x-axis. I'm just drawing the positive parts. Let's just draw one vector. Suppose yung v ko has components 1 and 4. Okay. So it starts from the origin, and then yung terminal point niya will be the point 1, 4. So 1, and then 1, 2, 3, 4. So this is now the vector. So pag kinonect ko tong dalawang points, I will have the vector v. Okay, label natin, this is the vector v. Let me create another vector. Let's call it w. Okay. It will have components 3, 1. So 1, 2, 3, or maybe adjust ko yung distance ng mga tick marks natin. So 1, 2, 3. Ito yung terminal point niya. And this is now the vector. Ulitin natin. Dapat straight. Ayan. This is the vector W. Now, from the definition, V plus W will have components 1 plus 3, which is 4, and 4 plus 1, which is 5. So, locate natin yon. So, 4, 5, 1, 2, 3, 4. 1, 2, 3, 4, 5. So, ito siya. And, let me use a blue. So, itong blue vector, ito ngayon yung vector na V plus W. Okay. Now, we have two methods for drawing the sum of two vectors. So, suppose hindi nyo alam yung mga components, so arbitrary yung components, how would you draw geometrically the sum of two vectors? So, we have the parallelogram rule. Parallelogram rule. So this is the first method. According to the parallelogram rule, if we have a parallelogram and the sides are V and W, then V plus W will be the longer, so it will be one of the diagonals of that parallelogram. So again, V and W yung dalawang sides ng parallelogram. Ito yun, V and W. Let's draw the parallelogram. Yan. Maybe let me shade the parallelogram. Let me see kung meron akong tools dito to actually shade. Okay, meron. Shade natin with yellow. Hindi ko gusto yung itsura. Bawasan natin ng thickness. Siguro 10. Ayan. So, itong yellow region ngayon, ito yung parallelogram natin. Ayan. And as you can see, itong V plus W na drawing natin kanina, it's now this diagonal of the parallelogram. So, kung arbitrary vectors, halimbawa ito yung V, ito yung W, then ito yung parallelogram natin. Ito na ngayon yung V plus W. It will be this diagonal na nandun sa opening ng dalawang vectors. So, kung ito yung V, ito yung W, ito yung V plus W. So, that's the parallelogram rule. Now, we also have the head-to-tail rule. Okay. So, according to the head-to-tail rule, to add two vectors, ang gagawin nyo is you will connect the head of one vector and the tail of the other vector. So, dito sa example natin, gusto kong i-add ang V and W. So, I will connect V. So, ito yung V. So, dito sa head ni V, I will connect the tail of W. Ayan. Ito naman si W. And then, all I have to do is connect the head of W with the tail of V. Ayan. And as you can see, if I can actually draw the vector properly, mahirap. Medyo madulas yung pen tablet ko. Okay, please assume na straight ito. Ayan. This is now V plus W. So again, connect the head of V with the tail of W. And then, now your new vector, which is V plus W, will have initial point will be the tail of V. and terminal point will be the head of W. Ayan. Now, what happens if we multiply a vector by a scalar? Okay. So, I'm going to recycle V here. 1, 4. Okay. Suppose gusto kong i-multiply itong V ng 2. 2 times V. So, according to the definition, i-distribute ko lang yung 2 dun sa mga components. Magkakaroon ako ng 1 times 2 which is 2 and 4 times 2 which is 8. So, i-drawing natin yung vector na yon. So, again, let me draw the Cartesian plane. Ayan. Let me plot again vector V with components 1, 4. So, 1, and then 1, 2, 3, 4. Ito ngayon ang vector V. Ayan. Let me try the arrow tool. I have an arrow tool here in my PDF reader. Yeah. That looks so much better. Dapat yun na lang yung ginamit natin sa simula pa. Okay, now, let's locate the vector 2, 8. So, 2, then 1, 2, 3, 4, 5, 6, 7, 8. So, ito siya. Okay. Maybe let me use a different color. Gamit tayo ng green. Gamitin natin 50% yung transparency. Ayun. Okay, so what do you observe? So, what you observe here is the direction of V is preserved. Direction of V is preserved. But, yung magnitude natin, it is multiplied exactly by 2, which is yung minultiply nating scalar. So, ang nangyayari kapag nag-multiply tayo ng scalar, na-i-stretch or nasi-shrink yung vector natin. So, kung 2 yung minultiply natin, dumoble ngayon yung magnitude ng vector. Kung 1/2 yung i-multiply ko, mangangalahati ngayon itong vector. Okay. Pero, yung direction natin ay nape-preserve. And that happens when yung scalar na minumultiply ko ay positive. Kung negative 2 yung i-multiply ko, I will get the vector negative 2, negative 8. Okay. So, let me extend my Cartesian plane. Since meron na tayong negative coordinates. Ayan. Negative 2 is here. And then negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Then let's draw the arrow. Terminal point muna. And then the arrow. Okay. So, what do you notice here? Okay. So, ang nangyari, so yung vector natin, na doble yung magnitude niya, pero yung direction niya ay bumaliktad. So, the direction of V is preserved if K is positive. And then, the direction of V is reversed if K is negative. So, na-stretch yung vector natin kapag yung K natin, yung absolute value niya ay greater than 1. So, if the absolute value of K is greater than 1, the vector is stretched. And if the absolute value of k is less than 1, for example, 1/2, so mako-compress ngayon yung vector natin. Yan. So what about subtraction then? So subtraction of vectors, so v minus w, yan. This is just the same as v plus negative w. So let me just check on my space pa ako dito. Let me draw the vectors here. Okay. I'm going to draw a different v and w, not the same as this one kasi medyo limited na yung space natin. So suppose ito yung v, ito naman yung w. Now v minus w will be v plus negative w, but nasan ngayon ang negative w? Let me draw negative w with a different color, for example red. So same magnitude as w but opposite direction. Ayan. So itong red na vector which is negative w, ito yung i-add natin sa v. So ito yung v, ito yung w, ito yung negative w. Okay, since we're adding v and negative w, we can either use the parallelogram rule or the head-to-tail rule. Let me just use the head-to-tail rule. So i-connect ko sa head ni v yung tail ni w. So ito ngayon yun. Therefore, the resulting vector is this. So this is now, itong purple vector na to is v minus w. Now, if you notice, that purple vector is identical to this vector. Ayan. So another way to draw v minus w is to draw this triangle. So ito yung v mo, ito yung w mo. Ayan. You just need to draw a vector from w, okay, mula dun sa vector na sinusubtract mo, papunta dun sa vector na v. So this is also v minus w. Okay, so I want to summarize all of these. Let me check if I can actually add one page. Is it possible to add one page here? Okay, mukhang hindi. Okay. Because I want to summarize what the operations look like. Okay. Sige, let's use the space here. Anyway, this is just simple operations on the vectors. Let me use the space here. Okay. So summarize natin. If this is v, if this is v, and this is w, then all we have to do to produce v plus w is to, if we're going to use the head to tail rule, I will connect the head of v to the tail of w. Ayan. And then I will connect the head of w with the origin. So ito yung v, ito yung w, ito yung v plus w. And then kung subtraction naman, if this is v and this is w, okay, what I'm going to do is connect the head of v to the head of w. Ayan. So this is v, this is w, and this is v minus w. Now, for scalar multiplication, it depends on whether C is positive or negative. So, ito yung V. And if the scalar is positive 2, for example, then dodoble yung magnitude ng vector natin. Pero, same direction. Yan. So, ito K positive. Okay. Kung negative naman, the direction will be reversed. Okay? Medyo magulo yun. Medyo magulo tong mga arrows na to. Ganun. Okay, so ito yung vector na makuha natin kung negative naman yung K. Okay. So these are vectors kv when K is positive. This is also kv when K is negative. Okay. So yan yung nangyayari geometrically when we add, subtract vectors and when we multiply vectors with a scalar. Ngayon, sagutan natin itong example na to. We have V with components negative 2, 0, and 1, and W with components 3, 5, and negative 4. Okay, this is just a simple exercise. V plus W and is just the vector where we add the respective components. So negative 2 plus 3, 0 plus 5, 1 plus negative 4. So we will get negative, 1, 5, and negative 3. Now, 3V is equal to 3 times the components of V. So 3 times negative 2, 3 times 0, 3 times 1, and we will get negative 6, 0, and 3. And then negative W, inenegate lang natin yung mga components ng W. So negative 3, negative 5, and then negative of negative 4, which is positive 4. Now let's compute W minus 2V. Okay. We're subtracting from W negative 2 times the vector V. So ito ngayon yung components ng W. Sulat muna natin. And then minus the components of 2V. So that's negative 4, 0, and 2. And then, saka natin i-subtract. So 3 minus negative 4 is 7. 5 minus 0 is 5. And negative 4 minus 2 is 6. So the components of W minus 2V are 7, 5, and 6. Okay. Now in the next theorem, we have the properties of the vector operations that we just discussed. Okay, so no need to memorize this. You just need to understand what's happening. So dito sa number 1, it shows us that vector addition is commutative. U plus V is equal to V plus U. Dito sa pangalawa, it shows us that vector addition is associative. Quantity U plus V plus W is equal to U plus quantity V plus W. And then, sa pangatlo naman, U plus the zero vector is the same as 0. The zero vector plus U is equal to U. So the zero vector acts like the usual number 0. Nandito sa number 4, U plus the negative of U will be the zero vector. Or you can actually write U minus U is equal to the zero vector. Dito sa number 5, if we have K times L times U, where K and L are scalars, K and L are scalars, then that's equal to quantity K times L times U. And dito sa number 6, What it's telling us is, pwede nating i-distribute yung scalar when we are adding two vectors. So, k times quantity u plus v is equal to k times u plus k plus v. So, number 7, if we are multiplying the sum of two scalars with a vector, pwede nating i-distribute yung vector. So, quantity k plus l times u is equal to ku plus lu. And then finally, number 8, the number 1, the scalar 1 times u is equal to u.